about that. Oh, that's caught up. We'll get started in just another minute. Okay, good morning. We have 15 students. Can all of you hear me? Is there any problem with that? Whoops.
No.
Okay. Can you see me?
Yes.
You can? Oh, and then there's a problem. No.
Yeah.
Can you see the screen?
Yeah.
Sharing the screen. Okay, you get the pattern. All right. Again, I hope, definitely hope we'll have more students coming on in the next few minutes. No, it's a little hard to get up, but an old guy like me can do it. You guys can. All right, let me say something here. I don't like to say this, but I was disappointed. Notice that, again, my recent announcements, once again, and you folks are doing it, but once again, check your Valley College email and especially your Canvas site or shell here every day, because there's going to be some changes and some additions and so on. And what was referred to here is that maybe I didn't make it clear. Or I was being a little ambiguous about the assignments. On Tuesday, I gave you 5 assignments to do. And I was really hoping to see a lot of those come in on Tuesday and certainly Wednesday. If we have 5 assignments, hello, Jack. That's my little dog, only one of them. Jack, you want to see the ones? Come here. Come here. All right, this is Jack. And Jack, don't look so scared. Oh, you just want to eat. Go on. All right, I'm sorry. Anyway, so if there are 5 assignments on Tuesday, and I have about 40 active students in the class, that's 200 assignments I need to grade. And I've given you another assignment. You actually have 6. We'll look at that in a moment. So here's what I guess I'm saying is that, and I want to give you some time in class, so to speak, to do these. As I said on Tuesday, I think you could probably do all of them in about a half an hour and so on. I'd like you to try to get these in now, okay? Now, I'm going to be out of town on Saturday. I'm leaving to go out of town on Saturday, and I won't be looking at or grading anything until I come back on Wednesday. So while you do have, at least right now, as far as you still have until Sunday evening to do it, I really would like to see lots of assignments coming in today and tomorrow. Okay, so I can get them graded and you can move along and so forth. I'm not going to accept anything after midnight on Sunday. And again, I won't be looking at anything on Saturday and Sunday anyway. So help me with that. And I just want to keep you moving along and getting, not waiting too long. I know one of you wrote to me and said, you know, you really have a problem with until you need to get to the weekend and do it. And I understand that's why. And it would you, I think, if you would just try to get some of these done during the week. And again, you've got your assignments. Okay, so here's week 4 now. Let's take a look at this for a moment again. And there's this bookend. I like to think of it as a bookend. There's the read this first at the top and this Zoom summary at the bottom. And as you can see, there's a summary for Tuesday. That's the date, 22nd. There'll be a Zoom summary for today too. And you can see in week 3, there'll always be 2 Zoom summaries once we get it all done for that week. So you have this up here, read this first and Zoom at the bottom for your bookend. And then in between, you're always going to have exercises and that. I think every week we'll have some exercises and activities. And then once in a while, a solder project. And your second solder project, the one after the solder practice kit, will be coming up pretty soon. But anyway, you have 6 assignments to turn in this week, 5 of which we talked about on Tuesday. 3 of which are exercises, exercise. And then there are 3 activity. And again, there's a new one here, which an exercise, which I'll show you in a moment. So that accounts for the 6 that are here. 1, 2, 3 exercises, 1, 2, 3 activities. Then in addition to that sort of thing, there may be some other sheets here for you to look at. For example, there are these demo projects. I'm going to try to do a demo every day, every Tuesday or every Thursday. This is the demo project I showed you on Tuesday with the 2 RGB LEDs spinning around. And I think it's rather dramatic. Today, I'm going to show you this one, which is a star flasher. And when I say show you, I have all of these projects to show you. This is another RGB one that you'll look at in a moment. Also, I want to just check this out with you. We'll look at this. And again, I don't expect to be here all period today because I want to give you some time to actually work on those activities and exercise. I asked you on Tuesday, I mentioned on Tuesday, if you have anything you think that we should look at and show, please send it to me. And I'm not quite, Michael, I think, sent me this guy, Great Scott. He's an interesting guy. I think he's from Australia and so on. And he has lots of things he's doing, very interesting. And some of them are quite advanced. But the video I went to his site, I picked up this video, and I want to show this video to you because it has some interesting soldering techniques and whatnot. So we'll look at that in just a bit. These aren't activities you do or exercises you do. But they're there for a reason, and I want you to look at them. So let's go back here for a second and look at this current limiting resistor. Some of you have done this, and that's fine. And I just want to point out 1 or 2 things that will help you if you need to. Okay, so you have this video, blah, blah, blah. Now here's the circuit. And you're going to do some calculation here. What we want to know is the value of resistor R1. Battery, a resistor, a current limiting resistor, and an LED. You know, if you put this LED across 3 bolts, typically 3 bolts on your coin cell, you don't need a current limiting resistor. That's one of the activities you're going to do. But if you put it across anything more than that, you need something to limit the current flow. We want to know the value of that resistor, and we're going to use Ohm's law, an aspect of Ohm's law, which I'll discuss more in detail next Thursday. And this is the formula we're going to use to get it, to find out the value of that resistor. R equals V over I. The thing is, R equals the voltage across the resistor divided by the current flowing in the circuit. This is a series circuit. And you will learn later, as emphasized, that if you know the current anywhere in a series circuit, you know it everywhere. So if I tell you that the current flowing through the circuit is 18 milliamps, that's what we need to light the LED, then that's the same current flowing through the 360 ohm resistor. So the question is, with this formula, if we know V and we know I, we can do the calculation. Some of you taking pre-calculus and calculus, I think you can handle this. The thing is, you must understand that if I give you a problem with this example, I gave you the problem, said we have 9 volts. We're starting out with 9 volts. Well, that's not the voltage you put in this formula. 9 volts is the total voltage here. Each one of these components gets a portion of that 9 volts. And if the LED gets 2.2 volts, then what's left is for R1, which in this case is 6.8 volts. You subtract 2.2 from 9 and you get 6.8. And that's the voltage you use in this formula because that's the voltage across the resistor. The current, you're given it 18.8 milliamps. So look at the example, and when you work out the problems, be sure you're subtracting 2.2 from the stated voltage. 12 here, you subtract 2.2. 18, you subtract 2.2, because that will give you the voltage across the resistor. Another thing, of course, is that you'll be given numbers in milliamperes, which is 1,000th of an ampere. You need to change that milliamperes to amperes to put it in the formula here. You do that by moving the decimal point 3 places to the left, always 3 places to the left. So with 20 milliamps, you need to move it 3 places to the left. That's the number you plug in, and boom, boom, boom. Are there any questions about this exercise? Okay, I think you know, again, some of you are in pre-calculus, calculus, everything. I know you know. You just have to look at that. All right, so the blue LED exercise is something you read and you answer a few questions. I think you'll find it interesting how that blue LED came about. I'm going to look at this in this. Okay, this is your new exercise. I've given you a new exercise. I just figured you didn't have enough to do, so I would give you more. You're probably thinking, oh my God, what's this guy doing? But let's take a look at this one for a moment. Okay, so this is LED pinouts. There are LEDs with more than 2 leads, and I want to take a look at what they might mean. And this is a fairly good sheet on it. Most LEDs are just, but some of them large package. Take a look at this. Now, this is a little circuit that we looked at already, and LUT stands for LED under test. Well, okay. Current limiting resistor, 5 volts, negative through the LED up here. That's our circuit. And again, you can read, so I'm just gonna hit the highlights here. So a 2-pin LED, well, that's the typical LED that you have. A 5mm LED looks like this. There are 2 ways to determine which is the positive end or the negative end. And one is the length of the leads. The positive is longer, the negative is shorter, always will be in electronics. There's also on these 5mm LEDs, a little flat spot on the lens here. Take a look at your LEDs and you'll see that. And so even if you cut these leads even, you should be able to tell which is the negative because the flat side, the lead next to the flat side is negative. Anyway, here we are. But you could put 2 LEDs in one package and still only have 2 leads coming out like this. And you can see what's going on here. One could be red and one could be green. But they're not going to light at a time. Because remember, an LED needs a positive on the anode, negative on the cathode. So over here, if we make this lead positive and this lead negative, this LED lights, the green one. But the red one doesn't, because it has, wait a minute, let me back up, sorry, let me repeat. Bite my tongue. If we make this negative and this positive here, then the red LED will light because the anode on the red LED has a positive and the cathode has a negative. But not the green LED because it's backwards. If this is negative on anode, it won't light. If this is positive on the cathode, it won't light. But if we turn it around, we turn the polarity around and make this end negative and this end positive, then it's the green LED's turn to light and the red one does. And we can do that. And so we have 2 LEDs in one package. Also, what's very important is we can apply alternating current to these leads. AC, back and forth, back and forth. And of course, we'd have a flashing LEDs, green, red, green, red. That's kind of cool. There are LEDs with threes, and you could have a setup like this, where the cathode end of both LEDs is connected to one lead, usually the middle, and then you could either turn on a red one or a green one, or both, or both. Okay. 4 LED, 4 leads. What's that all about? Well, here's a potential. Again, common cathode connections in common, and then the other, you put a positive voltage here, the red one will go on, put a positive here, the green, put a positive here, the blue. 6, the guy looks like a octopus coming, well, or something like that. Well, these are independent. You can see there's 3 independent LEDs, each with its own cathode, each with its own anode. You could come up with a pattern like this. And then there are just some questions here. 1, 2, 3, 4, 5. Just answer those 5 questions. Take your time, and then you've done the exercise. Any questions? Okay. Good. Well, we've got 20 students. That's good. I'd like to see 30, but okay. So once again, exercise. Where are we? The current limiting resistor exercise we talked about. Blue LED. Read that, and then the one we just went over a second ago here, the multiple pins. Then, as far as activities are concerned, you are to test an LED with a little coin battery. You should get a coin battery if you don't have one. You just need one. You can check all your LEDs with those without using a current limiting resistor. The bar LED, where you measure you determine which, if the LEDs light on the bar. Look, they're going to be, they're going to work, but at the same time, you have to understand how it's configured. It's not hard. Just place this across the channel. Again, always look at any of these videos. This is 30 seconds. We looked at it on Tuesday. This little notch tells you that these ends are the anode and the other ends are the cathode. And, you know, check them out. And you'll use that bar later on in the course for all kinds of things. But you've really got 10 LEDs in a nice, what's called DIP package, dual inline package. That'll fit nicely. Flashing RGB LED and LED, we've gone through that, and there's not much to do with that, but you'll see. We've demonstrated the spinner project on, so that, I'm sorry, let me back. That takes care of all 6 assignments, 3 exercises and 3 activities. The demo project we saw on Tuesday, this one, let me show you this one. This is this 5-star project here. And here it is. The exact one that you see there, I built here, okay. And they use RGB LEDs, and here's what happens. And again, it's not too dramatic because the lights are, my lighting in my room is crummy. But it goes through a whole sequence of pre-programmed. There's an integrated circuit in here. It's been pre-programmed to go through some very dramatic patterns, which I think is really kind of cool. You can build this. I mean, you're ready, I think. Follow the instructions. With projects with lots of LEDs, the big issue is to make sure you get them in the right direction. That's the key. And I built one, I'll show you at some time, with 360 LEDs. And boy, getting those in the right direction is the key. Again, this is much more dramatic than it's showing you there. In fact, let me just show you. This is the Amazon site where you can buy this thing. And again, if you want to make these things, and I'll be glad to give you some extra credit for it. Again, it's not required. You can certainly earn an A in my class without building any of these extra projects, but it's kind of Cool. All right, so here it is. It shows you the different pictures. It comes with it does come with this plastic case. What's it selling for? 20 bucks. Sorry, 18.9. It comes with this beautiful plastic case, but I didn't mount it on that. I mounted it on my clipboard. You have an integrated circuit here that goes in the back, and this guy's gone nuts with these. We're going to look at this Christmas tree, really a very dramatic project too, an RGB project, which we'll look at when we get closer to Christmas. But let's just take a few here and look. This is red, doesn't matter. And you can run it on a battery, which I've been doing. Mine was, I just have it portable on batteries. You can plug in, of course, to 5 volts, connected to your computer. Again, with RGB LEDs, you can come up with any color, virtually any color. All right, so okay, you get the okay, so let's see where we're at. We're just about through. So what we've done today is we've looked, again, read this. This one tells you about the 5 assignments you have, but I added 1, so there's 6 now. 3 exercises, 3 activities. We looked at a demo here, just now. Oh, well, let's take a look at this. Let's take a look at this. This is this great Scott guy, and I like his accent. And great Scott. All right. So he's going to show us how to build this VU meter with these various LEDs he spells out as music. And I'd like to look at this. It's about 10 minutes, and then we'll be through for the day. But let's take a look at this. There's a lot to be shown here, a lot of them. And when you do, this is what comes up. So this is the one you want to click on here. Make your own LED sign, your VU, volume unit meter. It's kind of like a color organ, but it's more than that.
Ever since I started creating electronics videos, there's been one repetitive question. How did you make the LED sign in your intro? And the answer is super simple. Dozens of LEDs stored in parallel and powered by a constant voltage source. But since that is too easy and even a bit boring for an electronics project video, I will now show you how I created a new LED sign that features a volume unit or VU meter circuit that lights up the LEDs in correspondence with the loudness of the music. Let's get started.
So that's what he's going to do. And I'm interested in his solder techniques and the boards he's using. It's not even 10 minutes, only 5 minutes. And you can see he can really work fast. And his soldering is unbelievable.
First off, we're going to need the LED sign itself. For that, I used the software Lochmaster with a strip or template to create my initial design by placing 73 green LEDs on the board to form the word music. Then I printed it out, gathered my LEDs, and started placing them on the board in order to write the first letter.
Now these are perf board. It's called perf board. Spacing on all of these holes is 1/10 of an inch, which is pretty much the spacing on the leads of everything you're going to work with in electronics, not all entirely. And this is a blank side you can see here. When he turns it over, you'll see the other side is copper.
Make sure though that the anodes and cathodes all face the same direction. In my case, the anodes face upwards. To solder them in place, I simply bend their leads and after soldering, snip them off. But since this tactic does not fix the LEDs in the designated spot very well, I heated up the solder afterwards once again and pushed a bit from the other side. This way, the results look pretty decent. I then repeated this process for every one of the remaining 4 ladders, which took about half an hour. Afterwards, I got a 0.8mm silvered copper wire, straightened it out with the help of 2 pliers, and formed 6 bridges which jump across 2 holes of the strip boards. I used those around the ladder I to connect all the anodes of each row together in order to create a so-called common anodes. At the end, I soldered a wire to each cathode line and 1 extra wire to the common anodes, and the LED sign is complete. I tested it out by applying the forward voltage of this LED type to the common anode and each cathode line. And it's to work about.
So see, he's done he's all these LEDs in, and he's made them with common anodes, and so that's fine. But now what's going to happen in the rest of the video, he's going to add the circuitry to make it respond to the music.
We can move on to the control electronics. This is the schematic that I came up with. Looks confusing at first, but let me explain. The main input signal will be the AC voltage of a 3.5mm jack, which produces maximum voltage peaks of around 1.3 volts. That is quite low if we want to distinguish them between 7 threshold values for the 7 rows of the LED sign. That is why I'm mono signal to fine adjusted by a potentiometer.
All right, yeah. But notice he's using the solder of the circuit board to test these things out, which you have now. And
what we want in the end are peaks of around 8 volts in the amplified audio signal. This way, we can build up 7 comparator op-amp configurations, which will turn on its outputs when the voltage of the plus inputs, aka the audio signal, is higher than the voltage of the minus inputs, aka the reference voltage. And by creating reference voltages from 1 to 7 volts with the help of voltage dividers, we successfully differentiated between the volume levels, also known as the voltage amplitudes of the. Those output voltage bursts can then be connected to the gate of 7 RFD 220 N-channel MOSFETs, which finally turn on and off the individual rows of the LED sign. I only built up the circuits for the upper 3 rows, 7, 6, and 5 volt on the breadboards, but nevertheless, it demonstrates the principle pretty well. So I gathered all the parts I need for the complete control circuits and started by soldering the audio and DC jack to the left side of the board.
So, once he did it on the side of the circuit board, now he's going to go ahead and make it permanent.
According to the schematic, I then added the mixing resistors, the potentiometer, 2 4-pin IC sockets for each quad op-amp IC, the MOSFETs with some resistors, all the resist amplification, While creating kits, I try to use silver copper wire as often as possible to keep the layout neatly arranged. But in the end, I was forced to use a bit of flexible wire to hook up the op-amp outputs to the gate of the MOSFETs. And after 2 hours of soldering, it was time for the first test. So I connected a 12-volt power supply to measure the voltage at the ICs and the reference voltages, and used my oscilloscope to verify a successful amplification of my audio signal. Afterwards, I mounted a buck converter to the board, hooked it up to the 12-volt power line, set its output voltage slightly higher than the 4-volt voltage, connected the positive outputs to the common anodes and the cathode lines to the drain of the corresponding MOSFETs. Then I drilled 3mm holes in each corner of the 2 boards, used 20mm spacers and M3 bolts to join them together, and the project was complete. With the help of the potentiometer, the circuits can be adjusted to pretty much every audio signal, and of course, it does look awesome, especially with the lights out. I hope you like this project, and if you want to build something similar, you can find all the necessary information in the video description. Don't forget to like, share, and subscribe. That would be awesome. Consider supporting me through Patreon in order to keep such videos coming. Stay creative, and I will see you next time.
Okay, so he's kind of, and I've seen a couple of other videos he's done. They're very good. It's complicated stuff, but it gives you some idea where you can go with this sort of thing. This is not impossible to do. But, I thought you'd like that. Okay, so that's pretty much it for week 4. Again, I'm going to be in and out today. When I come back and look at my computer, I want to see lots of activities, lots of assignments coming in, and especially tomorrow. Because again, I'll be out on Saturday. So again, there'll be no YouTube video next Tuesday, but there will be on Thursday. And I have also gone ahead and published week 5 material. We just first, I'll be adding a little bit here and then, as I always do. But there's more sophisticated metric conversion units for exercise, for week 5, and then we'll get into Ohm's law. And, but it is something you could look at ahead of time. But the main thing is to get this stuff finished. Okay. Any questions? Let me do this. Let me, oops, let me get rid of that share. Stop the share. Ah, there, I like that picture better. Kevin, how are you doing, Kevin? Can you hear me, Kevin? That's done. Kevin?
Yes.
Yeah, good. You sent me something this morning and I couldn't open it up. If you try to send me another round.
Yeah, I already sent it in because I
Oh,
sent it in,
great.
a zip file, so you don't have to download every single file.
Yeah.
But I sent every single file in this morning.
Thank you.
Yeah, thank you.
Okay, so again, 20 students. This is what's happening. We're getting about half the ones that are still in the class. And okay, I'd like to see more. I guess I needed to make sure that you get something every time we talk. Otherwise, you say, it's just not doing much, not worth it. I know some are working and just cannot come. Some are working and coming. I see Joseph's at work, and it looks like Bobby's working hard over there. What are you doing, Bobby? What, you're wiring up?
I'm an electrician, and I'm just wiring up some outlet.
Well, sorry, as long as you're doing some electrical electronics, it's okay.
Yeah.
All right, so it'll be a week now before I see the rest of see you again. Try to get as much as you can in today and tomorrow, and I can get it graded and go from there. Are there any other questions? Or okay, we're about. Okay, then why don't I let you go? We're already through with the 4th week. You're doing well. Those of you who are turning in material, you're turning it well. And
Professor,
yes,
I always been sending my assignments on your Valley Gmail.
Mm-hmm. Yes, that's good. Ryan?
Yeah.
All right, so Ryan, just a second. Yeah, I've got everything from you, Ryan. Everything's fine.
I like Ohm's law. It's like easier than algebra.
Yeah, I mean, it's the Ohm's law formulas are about as simple as you can get. You know, and Ohm's law, as you will see, is the most powerful and significant law in electronics.
Yeah, like the funny part when I tried looking at the German version, the R V over I, but in the German version it's R U over I.
That I've never seen.
Go look it up at Ohm's Law Wikipedia and go into the Deutsch. the German language and see the circle. It's super weird.
Well, yeah, you will see E as for voltage in the United States. When I was going to school, it was not V, it was E, electromotive force. And there are still, you'll still see that from time to time, where again, voltage is expressed with the letter E instead of V. That changed about 40 years ago, but it's not a big deal.